Hello, it's a pleasure having you guys aboard for today's presentation. My name's Darryl Whitaker. We're going to explore some of the basic concepts of virtualization. If you're not familiar with VMware products or virtualization concepts, you should find this video. We'll take you back to the basics where we'll discover what a virtual machine is. We'll explore some of the benefits of virtual machines. We'll also discuss how we run and manage virtual machines through the use of ESXi hosts and vCenter.
So let's start by discussing what a virtual machine is. The traditional physical architecture model that we used to follow probably 10 or so years ago was that we installed an operating system, a server operating system, onto a physical x86-bit server. And within that operating system, we installed whatever applications that we wanted to run. So maybe an email service, maybe a web server, whatever application it is, a database server or something like that. So what we used to do was, in order to isolate these apps from each other, for example, if you put your database server, your email server, and your web server all on that same physical server, if you had to do email maintenance, you'd now be affecting your web server and your database server. So we achieved isolation by buying more hardware and installing separate operating systems and putting these apps into separate hardware solutions, right? Now this was great, except it caused us to purchase lots of hardware. It helped us achieve isolation between these apps and improve services, but of course it was not a very cost-effective way of implementing isolation. So virtualization, or virtual infrastructure, takes that underlying physical server, and keep in mind that the hardware that we buy in these servers today are enormously more powerful than what we had 10 years ago, even 6 months ago for that matter. But instead of installing a thick operating system and an app in a one-to-one relationship, we introduced this concept of virtualization. And of course, virtualization is not a new concept. It's been around for some 40-something years, where IBM pioneered this concept of being able to share physical resources. So we install this thing called a VMware hypervisor. You may have heard of this called VMware vSphere. Other terms that we use, of course, is ESXi. But this is the operating system that we install onto the server that allows us to achieve virtualization. So what do I mean by that? That operating system has a job, and that job is to effectively, as an operating system, share the underlying physical resources, so what we call the core 4 resources, which I'll get to here in a second. So then we build these things called a virtual machine. Now, where things change compared to the physical model is, instead of installing an operating system and an app, now we create a virtual machine. And a virtual machine is kind of like a bubble, if you will, where we can build multiple virtual machines and share the underlying physical resources, because again, our hardware has gone beyond what we typically consume in a server operating system, which means that we can share the underlying physical resource to a certain extent and build multiple virtual machines. Now each one of these virtual machines is isolated from each other, and you can install an operating system and an app in each one of these virtual machines, and we can have multiple VMs on this underlying physical platform. And of course, we still can leverage things like centralized storage to achieve availability, like iSCSI, NFS, fiber channel, virtual volumes, vSAN capabilities, which I'll get into in our later presentations when I get to storage. But the idea, of course, is that we can share these underlying physical resources because we have larger capacities available. We can even go so far as overcommitting the resources, because if you think about it, not all these virtual machines require these resources at the same time. Now, we've got tools to help you manage and implement that safely. Again, we'll get into that in our next webinar or next video recording. So the traditional model was to take a physical install, the operating system, install the application, and of course it had exclusive access to the hardware in the physical server. In our virtual architecture, we install ESXi, and ESXi is a very thin operating system designed to share the underlying physical resources in the box. Now, with more architecture and more CPU and compute resources available in this platform, we have the ability to create these things called a virtual machine. And think of a virtual machine, like I said, a bubble or a software construct that isolates each operating system from each other. Now, of course, the operating system still needs to behave and gain access to CPU, memory, network, and disk space in order to obviously host the operating system, but also run the application. So the ESXi hypervisor gives us the ability to create these multiple VMs and share the underlying physical resource and overcommit. And the ESX hypervisor really, its primary role is to share the underlying hardware with these various machines that you might choose to run on top of their server platform. So why use a virtual machine? Well, if you think about that one-to-one relationship, made it difficult to move operating systems and apps from one hardware server platform to another hardware server platform. So it didn't provide transportability, or probably better said, availability. So it was more physically binding. It was difficult to manage, required physical maintenance anytime we needed that operating system or application. Sometime a maintenance or patch or reboot, we had to take down the entire system. And of course go through a reboot, which leads to downtime. Even downtime caused by hardware failures obviously was a big inconvenience, and availability for modern day businesses is very important. So hardware traditionally had its limitations. With a virtual machine, when we build a virtual machine, each VM is essentially in its own bubble, I should say, and we can encapsulate the virtual machine into a set of files. And each virtual machine is independent from the underlying physical hardware. So it's not binding to the physical properties and the physical hardware platform. It actually has a set of drivers designed to interact with the ESXi kernel more efficiently, but it's independent from the underlying physical platform. Which means if this virtual machine is embedded into a set of files and we put those sets of files into a central location, we then achieve portability. Because if we have multiple ESX servers and they're the same version, of course, we could power on and run that virtual machine on another host, supporting that capability. So through the ability to isolate these VMs from each other and insulate from hardware changes, we then gain the ability to not only run a virtual machine and share the underlying hardware, but achieve some of the transportability that we need in order to achieve availability overall. And I'll get to that in our next video. But virtualization also gives us the ability to support legacy-based applications. Think about that old Windows 2000 server that you have running an old version of SQL database that you're struggling to maintain, and if that server falls over, obviously you might be in some serious hot water and trying to be able to find hardware. If we could take that and put it into a virtual machine, obviously we're no longer bound to the underlying hardware. Therefore, we solve the hardware problem. It's probably a good idea to go out and work on the software problem as well. But it does allow us to support legacy applications in this model. It also allows us to consolidate and reduce the quantities of servers that we buy these days because of the additional resources that we have available in these modern x86-bit/64-bit architectures. So to describe the ESX kernel or the hypervisor's job really is primarily sharing these underlying Core 4 resources. And I think I mentioned these Core 4 resources earlier. So CPU, memory, network, and disk. So the hypervisor's job is to share these resources. In a one-to-one mapping, everything's pretty simple, right? Everything, the operating system and application has exclusive access to the entire hardware. So when we build these virtual machines, we can build a VM that has one CPU. We can build another VM that has two CPUs, another VM that has four CPUs. And we might only have four CPUs available in the physical server, but again, our operating systems may not be using all this capacity at the same time, and this is how we start to achieve consolidation, certainly from a CPU standpoint. So we can build these VMs with different virtual configurations, and of course those CPUs map to an underlying virtual CPUs map to an underlying physical CPU in order to do whatever computational value it needs to run. That doesn't change, right? It still needs the physical processor. If we take that a step further, we can also share the amount of memory in a physical server. So we can have a virtual machine that has 1 gig of memory. We can have another VM with 2 gig of memory, another one with 8 gig of memory. And again, they may not all require that total capacity of memory all the time. If they did, they'd be running at 100% CPU, memory utilization, and obviously they wouldn't be performing very well. But so quite often these operating systems are not using what they're actually given. So with that in mind, we can consolidate memory, and we might only have, say, 10 gig in this server, and we've given away 11 gig worth of virtual memory. The ESX kernel manages that sharing of that underlying physical memory, and that's its job in resource management. Take it a step further in our call for resources into networking. Now, our virtual machines can have a virtual network adapter. That virtual network adapter connects to other virtual machines through what we call a virtual switch. And then by the nature of adding a physical adapter into that virtual switch, we can then put packets on the wire. So this is think of it as a standard layer 2 store and forward packet switching concept. Standard layer 2 switch. And again, I'll get into the networking side in a future video here shortly. And we take that a step further. We have the ability to, instead of having dedicated storage in a physical architecture, we can connect to centralized storage and store virtual machines in a central location. Again, giving the ability to register a VM on another host and run that virtual machine from another host in a compatible ESXi architecture. So virtual machines are a software computer, not a hardware computer. And they're consumers of resources, just like an operating system traditionally would. You still need CPU, memory, disk, network, video card, etc. to gain access and to run the services that the operating system and application needs, right? That hasn't changed. What has changed, of course, is that we're sharing the underlying physical resources, and we can overcommit. And we map these to our virtual machines. So VMs are basically containers that run almost any operating system and application. They offer a segregation between virtual machines. So every virtual machine effectively exists in a bubble isolated from the other virtual machines. And the way this virtual machine communicates with other VMs is in the traditional sense via networking, or is otherwise permitted through SDK access in the kernel. But each virtual machine has its own resources. We map quantities of hardware into the virtual machine in what we call virtual hardware, and that virtual hardware maps to the underlying physical hardware to do what it needs to do. VMs generally do not realize that they're virtualized. So the operating system that we install typically has no awareness that it's virtualized. We will install a set of tools or drivers inside our operating system to work more efficiently with the ESXi host. However, the operating system has no idea it's virtualized. It just thinks it's a traditional operating system or a computer and runs as it normally would. Now, in order to separate each virtual machine into its own bubble, each virtual machine is isolated into a folder all by itself. And every virtual machine has its own unique set of disks and files that make up the virtual machine. So think of this as folder storage in an Explorer, where you create VM number 1 and all the associated files with virtual machine number 1 get stored in folder number 1. Whatever you've called your virtual machine. And again, this could be shared storage solutions of various different flavors. If you're interested, some of the files that make up a virtual machine, at a high level, I won't delve too deeply into them, but we have a configuration file, and of course you can imagine what that thing does. It tells us how much CPU, memory, network adapters the virtual machine has, as an example. Every virtual machine has its own BIOS, copy of the Phoenix BIOS, and that has a .nvram extension. So if you called your virtual machine Fred or Fred01, you would have a Fred01.nvram for this particular virtual machine. You'd have a Fred.0 or Fred01.vmx file for this virtual machine stored in that VM's folder. We also have log files. We have, if we're using virtual machine templates, a VMTX file. Our virtual hard drives have what we call a descriptor file and a data file. The descriptor file basically describes the properties of the virtual disk where data is stored. So think of this as if you installed an operating system onto a laptop, it would pick up the hard drive that's on your laptop and of course read the block structure and formatting structure of that disk, and then of course format that operating system or format the file system, and of course implement the operating system in that file system, etc. So the descriptor file describes the virtual disk, and then the data file is actually the large disk. So if you created for example, a 20 gig C drive, the 20 gig file would be fred01-flat.vmdk. This is the one that'll take up all the disk space. We have other files that are associated with the VMs as well, like if we create snapshots, if we're using change data tracking, other functionality, which again I won't dig into in today's session. So how do we run virtual machines? We talked about ESXi, right? VMware ESXi. So ESXi is the hypervisor that installs onto that physical server and allows us to create these virtual machines. It also allows us to share the underlying physical resources in these VMs. Now, it's a very thin operating system. It's a bare metal hypervisor. This operating system is small enough that we can actually load it over a network and using a network boot and load it directly into memory, so we don't actually require local hard disk in that server. ESX server installs directly on that physical server, is in control of all of the physical resources in that underlying operating system, and physical server I should say, and shares them with these various virtual machines. So those core form resources, CPU, memory, network, and disk. And allows our virtual machines to be run at near native performance. So there's not a big overhead for this hypervisor, unlike any other hosted hypervisor solutions. ESXi 6 allows up to 480 physical CPUs to be shared in a host. You can have 12 terabyte of RAM and up to 2048 virtual machines on a physical server. Now, to me, that begs a question logically, is that if I have 2,000 VMs on this physical server and I lose that host, or that ESXi host or physical box, obviously I've lost 2,000 virtual machines. So that's when we get into an availability discussion, which I'll expand on again in the next video. So the ESXi architecture, this kernel installs onto this physical platform, and of course we have a VMware management framework. So we have the core shell and a console that is our shell. The operating system, it's not like logging into a Windows box. It's a very thin operating system. It's not really designed for you to log in and have all these elaborate services and functionality running. It's designed to be that core hypervisor that shares resources and gives us the ability to create virtual machines. It supports an agentless system for management, for our management tools to be able to connect in and manage this as a fabric, if you will. We have command line integration configuration support, so we can do things like diagnostics on that physical server if we have faults. We also have agentless hardware monitoring using the common information model, and that's extensible and integrates with other third-party solutions for integration. And of course the core concept, which is providing and building virtual machines and sharing the underlying physical resources amongst those virtual machines. So how do we manage VMs? Now, we have a client that we can connect directly to a host and manage that host. But what happens if we have 500 hosts? If we had to log in 500 times to 500 different servers, obviously things are going to be very time consuming. So this is where we introduce this management tool we call vCenter Server. vCenter Server is a central management platform for the vSphere environment. vCenter Server will go out and add the hosts into vCenter. In other words, it registers the host, and that host becomes manageable through this centralized tool called vCenter. vCenter also brings to the table a number of other features, services, and functionality, which again we'll get into in further videos here. But it provides much of the features that come on top of, for example, vMotion, high availability, load balancing. It also provides SDK access into the environment for solutions such as VMware vRealize Automation. It's available in two flavors. We have a Windows installable edition. We also have an edition that comes in a Linux server appliance. So it's a Linux-based install if you don't want to run Windows in your environment. Both versions support the same functionality and features. So whether you use the Windows or the Linux-based appliance, that's up to you. Irrespective, you get the same functionality. A single vCenter server can manage up to 1,000 hosts and 10,000 virtual machines as an ultimate limit. Now, we're not just limited to a single vCenter. Of course, we can have multiple vCenters in large enterprises. This is quite common when we're running desktop-based solutions, virtual desktop solutions. So we can link these vCenters together and expand and grow the quantities of hosts and virtual machines in that context. vCenter has two components within its architecture. We have what we call a platform services controller. Services either come from the platform services controller or a vCenter instance. So the PSC offers single sign-on functionality. It provides license management service. It provides lookup services, VMware directory services, and a certificate authentication piece. vCenter also provides the basic functionality, which is vCenter, access to the vSphere web client, obviously to manage vCenter and all the hosts and virtual machines. We've got an inventory service for indexing and search functionality. I mentioned the ability earlier to deploy ESX across the network, and this is where we start to expand into other services that vCenter brings to the table, so what we call auto deploy. We've got other tools to help us with diagnostics, for example, ESXi dump collector and syslog capabilities that are embedded either into vCenter or gives us the ability to syslog out to an external service. So these tools basically bring this central management tool and functionality and bring the extensibility and scalability the way that we implement vCenter. So there's two basic architectures. A platform services controller. Now the platform services controller can either coexist with vCenter in what we call an embedded platform services controller, or they can be separated to run from separate servers or separate virtual machines, if you will. And obviously, separate virtual machine configurations is intended for scaling in the enterprise. So here's a couple of architectures, and these architectures are recommended architectures. So with enhanced link mode is a major feature that really impacts architecture and the way that we build this layout and configuration. So when using enhanced link mode, it's recommended to use the external platform services controller. And you can find out more details about this on our knowledge base article 2108548. But you can see here on the left with an enhanced link mode functionality without high availability. We have a separate VM for our platform services controller, and we might have two separate VMs leveraging the services of PSC and having two instances of vCenter. If we want to add high availability with enhanced link mode functionality, of course, we can have our two PSC controller configurations, as it's on the right-hand side of this diagram. Our virtual machine or server integration with load balancing, and that leads out to the various virtual machines with vCenter loaded in, and it helps us achieve high availability protection for vCenter based services. So at a high level, our architecture kind of looks like this with vCenter. Naturally, we've got the core distributed services that is the vCenter install in itself. These services include integration with other capabilities like vRealize Orchestrator and VMware Update Manager, just to mention a couple. The data and the configuration that is stored in vCenter exists within the database, and of course we connect to and support some of the common database servers within the industry, SQL and the likes. I mentioned vScenter, vCenter is what I'm trying to see, connects out to our hosts, and when we register those hosts with vCenter, not only does the host become manageable, any VMs that exist within those hosts also become manageable and registered in that central database which runs vCenter and basically collates everything into this central tool for obviously administrative purposes and configuration and build, etc. Naturally, of course, we have controlled access to what users can and can't do with role-based access, and we also have an API, and that API supports integration for our PSC, including single sign-on capability, which obviously supports various directory services. Microsoft AD is one of the obvious ones. We have integration between the vSphere web client through the API. We also have the vSphere client that works through the API, again authenticated and implementing role-based security, and other third-party applications and developers can tie into this with other plugins as well. So vCenter connects to a host, and you can see this diagram in the green up here. vCenter service that runs in the vCenter instance is called VPXD. Now this service connects out. Now when we go and add a host for management, initially the VPXD service connects directly to the host and you log into the host using root level privileges. Once you've connected to that server, then the host and vCenter start up a new service called VPXA. And VPXA and VPXD negotiate a secure password between each other. From that point on, vCenter VPXD communicates with vCenter or the VPXA service on the host, and they communicate over TCP UDP port 902, and we don't know what that password is. It's automatically negotiated. The service will automatically start. Now what this gives us the ability to do, of course, is the host daemon runs off root level privileges. So by setting a separate login identification, we can go back and restart that service. We can also reset the root password without impacting vCenter's ability to manage that host remotely. Now you can see here in the bottom right hand side of the screen TCP port 443 and 9443, the vSphere web client with single sign-on. You can see there is the web browser that we use to connect in to manage vCenter. We also have a traditional installable client with the vSphere client. That vSphere installable client can connect either directly to a host, again using port 902, or it can connect to vCenter using TCP port 443. So that is just a high-level overview of virtualization, what an ESX host does, and what vCenter does. In the next video, we're going to go and expand on some of these services and functionality. We're going to talk about things like our load balancing, vMotion, high availability, and how we achieve those as additional services that add on to or as functionality that vCenter brings to the table.
So that wraps it up for today's session. Please continue to the next recording to discover how we can move virtual machines from one host to another without any downtime, and ways we can use vCenter to load balance virtual machines across hosts and improve uptime in our virtual machines with high availability and fault tolerance. Thanks for listening. We'll see you next time.